start with this, just to recollect the concept. Type one. Solve it. One turn is not possible. The coil of a moving iron effective area of this much is degree per microampere. Okay. One is the effective area. You can take it as one. 0.4 into 10 to the power 5. 25. But did you read the question? You need it in terms of degree per microampere. So numerator should be in terms of degree, denominator should be in terms of microampere. .25 degree per microampere. Okay, let me do this. Those are online. Am I audible?
Yes, sir.
Okay, listen to this. The coil of a moving coil galvanometer has an effective area of 5 into 10 power minus 2 meters square. It is suspended in a magnetic field of value 2 into 10 power minus 2. Actually, it should be Weber per meter square. So make this correction. It is Weber divided by meter square, which is Tesla. Okay. So 2 into 10 power minus 2 Weber per meter square. If the torsional constant of the suspension fiber K is equal to 4 into 10 power minus 9 Newton meter per degree, then find its current sensitivity in terms of degree per microampere. Right. So what is the formula for current sensitivity? See, if at all you don't remember, right, I would suggest you write that one expression with which you can derive anything. What is it? It is NIBA is equal to K times alpha. So all that you need is current sensitivity. Current sensitivity is alpha by I. So alpha by I will be equal to, I will go that side, it will be NBA divided by K. So since they told effective area, I'm taking N into A itself. So how much is that value going to be? It is going to be 5 into 10 power minus 2 into what is the value of B? It is 2 into 10 power minus 2 the whole divided by, what is the value of K? It is 4 into 10 power minus 9. Right. So 4 will cancel this to 0.5 times. Right. So 5 into 0.5 is 2.5. So 2.5 into 10 power minus 4 divided. Where? No. 5 into 0.5 is 2.5, right? Now only I'm dealing only with the exponent values. Till now I didn't deal it. Okay. So 10 power minus 2 into 10 power minus 2, 10 power minus 4 divided by 10 power minus 9. How much is that? So it will become 10 power 5, right? Or can I write this as 0.25 into 10 power 6, right? So this is going to be in terms of degree per ampere. Since the ampere is a denominator, take this 10 power 6 to the denominator, it will become 0.25 divided by 10 power minus 6 degree per ampere. So the question they have clearly mentioned, they want the answer in terms of degree per microampere. So this 10 power minus 6 into 1 ampere is going to become microampere. So the answer is supposed to be 0.25 degree per microampere. Is the point clear? Yeah. Shall I proceed? Right. So we can try out one last problem that is based on this concept. Just do it fast. So take the data, apply the formula, tell me the answer, that's it. Make it fast. What is it? The class attendment only. The concept sorry, galvanometer, current sensitivity. Those are online, are you able to understand?
Sir.
See, what is the challenge in this problem? Can someone tell me, looking at the problem itself? See, till now, every problem, you had the answer either in terms of degree per ampere or radian per ampere, like that, where the value of angle was given only in terms of degree or radian. In this problem, it is given in terms of both. So they have given 30 degree and radian also. So you need to do some conversion and then report the answer. So please be careful with that. Did you understand the question in the first place? So what are they saying? Is there anyone who's not able to understand the question itself? You're clear? What is it? What formula to Ore formula? For galvanometer, there is only one formula. There is nothing else. I told you, one line I gave you an expression. Use that only. Don't think anything outside that. There is no out-of-box thinking needed for us. Just take the data and then solve. Okay. Let me help you out. Listen. The question says, a current of 200 microampere deflects the coil of a moving coil galvanometer through 30 degrees. Right. So if I break this question into two parts, when the current of 200 microampere was passed through a galvanometer, the amount of deflection it suffered was how much? Was 30 degrees. Right. Now what they're asking is, how much current are we supposed to pass through the same galvanometer to ensure that this time I don't want the deflection to be 30 degree. Can you convert it to radian? 30 degree is pi by 6 radian. Now, I don't want pi by 6 radian of deflection. All I need is pi by 10. Okay. So if I call this as I1 and theta1, the question they're asking is what should be the value of I2 so that the value of my theta2 is going to be equal to pi by 10. So just to clarify this, instead of theta, I'll use alpha. So both make difference. Pi by 6 is more or pi by 10 is more? Pi by 6 is more because the lesser the denominator, greater is the value. So logically tell me, even before you solve this question, right? What do you expect the value of I2 to be? Should it be greater than 200 or less than 200? It should be less than 200. If you get a value greater than 200, you're wrong. That is one thing you need to have in your mind. Did you understand why is it so? Because current sensitivity, because the amount of current you pass is directly proportional to the deflection the galvanometer pointer suffers. So what is the formula I told you? NIBA is equal to K alpha, right? This is what we need to apply. So if you look at all the parameters related to a galvanometer, since you are using the same galvanometer, what are all the values that are going to be the same in both the cases? The number of turns is the same. Is the current same in both the cases? If it is same, then there is no question itself. Current is not same. What about the magnetic field? It is same because you're using permanent magnets inside. They're going to produce the same amount of radial magnetic field. What about the area? Same. What about the torsional constant? Same. So what are the only two parameters that are changing? I and alpha. So to put it simple, I1 by I2 is equal to alpha 1 by alpha 2. That is all you need to do. Because what are the two variables? I and alpha. I is directly proportional to alpha. So I1 by I2 is equal to alpha 1 by alpha 2. So what is the value of I1? 200 into 10. Okay, I'll leave it as micro only. Okay. So final answer, whatever you're going to get should be reported in terms of microampere. 200 divided by what is the value of I2? That's what we need to find is equal to alpha 1 by alpha 2. Pi by 6 divided by pi by 10. So you're going to get 10 by 6. 10 by 6 or you're going to get 5 by 3. So 5 will cancel this 40 times. So I2 is going to be equal to 120 microampere. Makes sense. It is lesser than 200. That's the answer. Did you understand how to think? Right? So let me check the answer once. $120 microampere. Okay. So 120 microampere will create a deflection of how much value? Pi by 10. Okay. That is not all with the question. There is the second part also. What are they asking? They are asking you the current sensitivity. So when you want to calculate current sensitivity, calculate alpha 1 by I1 or alpha 2 by I2. Both will give you the same answer. So what is alpha 1 by I1? Pi by 6 divided by 200 microampere. So answer will be pi by 1200. Listen to this. Pi by 1200 radian per microampere. As long as your units are intact, you need not worry about what the final result is. Is this point clear? Suppose you report the answer in terms of degree, then what will it be? 30 divided by 200. So it should be 1 by 40. 1 by 40 will be 0.025. So that will be 0.025 degree per microampere. Right? Am I clear with this? Right. So these are all the problems based on galvanometer. Now, the last set of problems that we are supposed to try are based on conversion of a galvanometer to ammeter and voltmeter. So shall we get started with them? Yes. So just give me a minute. So we'll solve the problems which are based on conversion of galvanometer into ammeter and voltmeter, right? So first thing, for conversion of a galvanometer into ammeter, what are we supposed to do? We need to connect a shunt resistance. You remember shunt resistance is a resistor connected in parallel to the galvanometer, right? By doing it, what is the value of the shunt resistance that you need to connect? Rs is equal to Ig divided by I minus Ig into Rg, where Rg is the resistance of the galvanometer and Ig is called as the full scale deflection current. Remember, it's called full scale deflection current. Right. Next is what happened? Okay. So next is what is the resistance of the ammeter itself? If you recollect the circuit that is there, to the galvanometer, you connect a shunt resistance like this, no, which I'll call it as Rs, and this is Rg. This whole thing is going to act like an ammeter. So what is going to be the resistance of this? What is the resistance of the ammeter? It is going to be equal to, they both are connected in parallel. So when they are parallel, when two resistors are in parallel, equivalent resistance is R1, R2 by R1 plus R2. So it will be Rg into Rs divided by Rg plus Rs, and that's what is given here. Is the point clear? So that's going to be the resistance of the ammeter itself. It's not the resistance of the shunt. So coming from the beginning, what is the shunt resistance we need to connect? Shunt resistance that we need to connect should be Ig into Rg divided by I minus Ig. So what is the resistance of the ammeter itself? Rg into Rs by Rg plus Rs. You understood the reason also, right? Next. The next question is conversion of a galvanometer into voltmeter. So to do that, what are we supposed to do? You need to take a resistor with high resistance value and connect it in series to the existing galvanometer, so that what should be the value of the series resistance you are going to connect? The value of the series resistance that you need to connect is V divided by Ig minus Rg. So V divided by Ig, V is the voltmeter's maximum potential that it can measure. So V divided by Ig minus Rg, and what is going to be the value of the current that is passing through the galvanometer? So if you rearrange this equation, you're going to get V divided by Rg plus R. So I'll not suggest you to remember too many formulae. I'll suggest you to remember only two. Remember the shunt resistance formula. Similarly, remember the series resistance formula. Everything else can be rearranged and you can take the answer out of it. Okay. Next is, if this resistor is connected in series to the galvanometer. So galvanometer's resistance is Rg, and you're going to connect a series resistor here. So this whole device is going to act like what? This whole device, galvanometer plus that series resistor, is going to act like a voltmeter. So what is the resistance of the voltmeter itself? What is the resistance of the voltmeter? Rg plus R. So sometimes they'll ask you this question also. You need to be very clear on what they're asking. If they ask resistance of ammeter, put this. What is the resistance to be connected to convert it into an ammeter? Apply this. Read the question properly. Okay. Similarly, what should be the resistance that you need to connect to convert it to voltmeter? This one. What is the resistance of the voltmeter itself? This one. I hope you're done copying it. No? Shall we do some problems? Yeah. Yeah. See, question will be big, don't worry, but the solution will be small. Read it carefully and then solve it. At least now, did you guys check whether that half scale deflection experiment is there in your lab? It's there. So there you will be using all these concepts. So be clear with the theory part. So read it carefully.
Sir, your voice is not audible, sir.
Yeah. Is it audible now?
Yes, sir.
Yeah.
Now it is audible.
Yeah. Sorry, guys. I'll come from the beginning. They couldn't hear. Okay. So, what does the question say? A galvanometer with a coil of resistance 12 ohm. So, resistance of the galvanometer is 12 ohm. Shows full scale deflection for a current of 2.5 milliampere. So, Ig is equal to 2.5 milliampere, or it is 2.5 into 10 power minus 3 ampere. Am I right? So 2.5 into 10 power minus 3 ampere. The question is, how will you convert the meter into an ammeter of range 0 to 7.5 ampere? So what is the value of the current they are expecting the ammeter should measure? It is 7.5 ampere. So what is the value of the shunt resistance that you need to connect? R shunt is equal to Ig into Rg, the whole divided by I minus Ig. So what is this? It is Ig into Rg. Ig is how much? 2.5 into 10 power minus 3 into what is the value of Rg?
12.
12. The whole divided by I minus Ig. It is 7.5, right? 7.5 minus 0.0025. Am I right? Correct. Now observe, compared to 7.5, no, listen to this. This is one such approximation. We'll do it in many problems. So compared to the 7.5, there is a smaller value. So 7.5 minus this can be approximated to 7.5 itself. Okay. So 12 into 2.5, 25 into 12 is 300. So it should be 30. So 30 into 10 power minus 3, the whole divided by 7.5. How can I write 7.5 as 15 by 2? Okay, that is also right. 75 by 10, which is still going to give you a 15 by 2. So 15 will cancel this 2 times. So answer will be 4 into 10 power minus 3 ohm. So this is the resistance we need to connect in parallel to the existing galvanometer to ensure it is converted to an ammeter. Is the point clear? Right? So this is one such approximation you'll do for every problem that is based on conversion of a galvanometer to an ammeter. But you need to look at it. Don't do for every problem. You need to look at the value. Okay. Mostly IG will be very less because it's a sensitive device. Even for lesser current, it will be able to show full scale deflection. That is why if you see for 2.5 milliampere itself, it is showing a full scale deflection. Okay. Makes sense, right? So this is the first part of the question. The second part is, what are they asking? You need a voltmeter of range 0 to 10 volt. So V is equal to 10 volt. So what is the formula for the series resistance that we need to connect? What is the formula for the series resistance that we need to connect? V divided by IG minus RG. So V is how much? 10. So 10 divided by IG is 2.5 into 10 power minus 3 minus, what is the value of RG? It is 12. So 2.5 will cancel this 10 4 times. So 4 divided by 10 power minus 3, it will become 4,000, right? So 4,000 minus 12. So how much will the answer be? So 3988. So 3988 is the series resistance you need to connect to convert it to a voltmeter. Is the point clear? So if you see, the next question they are asking is, determine the net resistance for the meter in each case. So what is the resistance of ammeter and what is the resistance of the voltmeter? That is the part that's what the question means. So just now I gave you a equation. So what is the resistance of the ammeter? So resistance of galvanometer into the shunt resistance divided by Rg plus R shunt. Correct. See, maybe there you would have written it as RS. Right. This is okay, but I hope you understood. Resistance of galvanometer into shunt resistance divided by resistance of galvanometer plus shunt resistance. So what is Rg into RSH? Rg is 12. So what is the shunt resistance that we need to connect? It is 4 into 10 power minus 3. Right? So it is going to be 4 into 10 power minus 3, the whole divided by 12 plus 4 into 10 power minus 3. Right. Again, you can still do the approximation here. What will you do? You will write the denominator as 12 itself. So when you write it as 12, it is going to be 12 into 4 into 10 power minus 3. The whole divided by 12, cancel this and this, answer will be 4 into 10 power minus 3. This is approximated value. So 4 into 10 power minus 3 ohm. Is the point clear? So what about the resistance of the voltmeter? Resistance of voltmeter is Rg plus R series. What is the value of Rg? It is 12 plus 3988. So basically it will be 4,000 ohm. It will be 4,000 ohm itself. This is the resistance of the voltmeter. Okay. Direct பண்ணலாம் தப்பு You can check with your teacher though. That depends. See, mostly in all the problems, we do this approximation. Some teachers are very particular that they want the exact answer, then you go with it. As long as your logic is right. See, one thing you should understand, it will definitely be, I'll ask you only one question, tell me, okay? When you do it without approximation, is the value going to be 4 into 10 power minus 3? Of course, it can't be. Will it be greater than that or less than that? Why? Because the denominator is more. So this 12, actually, since it was exactly 12, they got cancelled, but the denominator is not 12. 12 plus something. So the value will be slightly lesser than that one, but almost close to 12 only. Are you able to understand? Because this 4 into 10 power minus 3 itself was derived by us through approximation. Okay. So let's check the answer. Look. 4 into 10 power minus 3. I told you, this approximation. 4 into 10 power minus 3. That is going to be the resistance of the ammeter. And for voltmeter, 3988, and resistance of the voltmeter is also 4000. Right. Right. So we have solved this part of the question. The next one they are asking is, when an ammeter is put in a circuit, does it read slightly less or more than the actual current in the original circuit? Is it going to measure lesser value or more value? Why is it so? Why is it so? It is because you introduce some resistance, no? There will be a small amount of current that is drawn by the resistor. Right? Actually, what is going to happen? You have the galvanometer here and you have the shunt resistance here. So this is the value of current which the device is supposed to measure. Had this itself been a measuring device, it would have exactly measured the exact value. It would have exactly measured the correct value. But what is happening, since the current is getting divided due to whom? Due to the external resistance that you added, the reading will be slightly lesser. In a similar way, what happens when you connect a voltmeter across a circuit? Is it going to have more value or lesser value? It is going to have lesser value on that, because there will be a potential drop across the series resistor that you have connected. There will be a potential drop across whom? Across the series resistor that you have connected. So the reason is, here what will happen? In the case of an ammeter, what will be the reason you will write? The reason you will write is a slight current is drawn by the shunt resistance. So that is why the value is going to be less. In the case of voltmeter, what will happen? There will be a voltage drop across the series resistor. So in both the cases, the reading will be less. Is that point clear? You can just make a note of it. I repeat, these problems are very important. You can expect them. Okay. So before I forget, just to remind you, the test will be held next week, not this week. Okay, I'll postpone it to next week for you to practice, considering the complexity of this chapter. Okay. எல்லாமே தான பண்ண ஆறு கிளாஸ் பண்ணியிருக்கேன் நான் ப்ராப்ளம்ஸ் அவ்வளவுதான் இருக்கு. அதான் பிசிக்ஸ்னாலே இது 2 தான்டா. சே, அது தெரிஞ்சு நான் என்ன பண்ண? வாட் இஸ்லாம் கேட்க மாட்டேன், ஸ்டேட் பண்ண சொல்லுங்க. Why do I want the history and all those things? See, you can expect these things, okay? You can expect, if there are any definitions, you can expect them. If there are derivations, of course, the chapter is full of derivations. You can expect the derivations and problems. Okay, these 3 will come. And just to inform you, we have already cut all the videos. So I'll try to give those videos in 2-3 days straight, in small capsules, so that whichever topic you're not able to understand, you can go that and see. Okay, so make sure that you utilize the videos part also. And these problems also will be given to you in terms of video format. So yeah, any doubt you have, you make sure you go through it. And when you're copying, right, you're copying the solution. I hope you're writing this number only. or you're writing something else? Are you using this number, example 87? Okay. Because if you have any doubt and you want to refer the video, you'll not be able to understand. So I'll give you the PPT for this. It will be on the study material tab, but still. Okay. So I hope this problem is clear, no? Can you try this? Data convert பண்ணிக்கலாம். தெரியலையா? Anyone else who could at least understand the question? So what are they saying? Can you explain whatever you understood? Okay. Okay. How did you get 3.6? 360 by 10. It is not a complete circle, no? How will you divide it by 360? And moreover, for a galvanometer, where is the pointer going to be? Center, no. So when you say 100 divisions, 50 will be on the left, 50 will be on the right. Correct, huh? Makes sense. Okay. And has a current sensitivity of 10 divisions per milliampere. That's the meaning. What is the meaning of it? What is his name? Shiva. Go wash it. The point to Parvala. I understand, right? It's fine. You can go. Parvala, sure. Concentrate. 10 divisions per milliampere. Abdina meaning. When you pass 1 milliampere of current, the deflection is shown for 10 divisions. Okay, well, that's another current sensitivity. If a voltage sensitivity meaning another, for every millivolt that you pass, for every millivolt that you supply, it shows a deflection for 2. So now you have only one expression. In the previous case, I told you there is only one expression to solve any problem based on it. What is it? NIBI is equal to so the rearrange panna, you will get current sensitivity and figure of merit. Current sensitivity in another alpha by I, NBA by K. So on the NBA by K is what is 10 milliampere, 10 divisions per milliampere. Adhe mari alpha by V nu irukilla. Alpha by V என்றது என்னது? Voltage sensitivity கொடுத்திருக்காங்களா? 2 divisions per millivolt. So இத மாதிரி இருக்குனா, what are the adoptions that you need? Means you first do an analysis of the galvanometer. So first rendu கொடுத்ததுல இருந்து what you can find is, if you look at the question till this step, no, it is actually from the previous model that we solved. Previous model, now what am I trying to say? From there, you will get a relation of what is the value of NBA by K and NBA by KR. So on the value, what you can do is, you need to do a manipulation to that existing galvanometer to convert it to 5 ampere for full scale. So it should become an ammeter. So 1 division per volt. So in the modification, what are we supposed to do? Actually, it is not ammeter or voltmeter also. இங்க பாத்தீங்கன்னா, I'll repeat it. Listen to this carefully. Okay, this is a very tricky one. 1 milliampere pass panna, how much deflection is taking place? 10, correct? So 5 ampere for full scale meaning another. So when I'm passing 5 ampere, it should show deflection for 100 divisions. So on the mari or manipulation pannanuna, what are all the parameters with respect to the coil we need to implement is what the question is. Purjada. Now I'm going to show you the solution. I'll show it for 2 minutes. Analyze it. Try to do on your. So I have only one question. Okay, I'll ask you this. Think and tell me whether you need to convert a galvanometer to ammeter or voltmeter. What is the important parameter that you need? You need to know the full scale deflection current of the galvanometer. So because you look at both the formula, what do you have in it? Shunt resistance formula, Ig into Rg by I minus Ig into Rg. Correct? So full scale deflection current kuduthirukangala? Kudukla. But what have they given? They've given the proportion accordingly. Enna proportion kuduthirukanga? 10 divisions per milliampere. Correct? So the meaning another. What is the meaning of 10 divisions per milliampere? So if I pass 1 milliampere of current, there is a deflection for 10. Okay. Yeah, there is a deflection for 10 divisions. Now, what should be the value of Ig so that I'm able to produce a deflection for 100 deflections? Unitary method. What is it? Ig evallo? So Ig will be equal to 100 into 1 mil. I'm not converting it to ampere. Okay, 100 into 1 milliampere divided by 10. So what will it be? No, 10 milliamp. Now you understood why this step came. Am I clear? See, it's very simple. You're looking at it, you can 10. 1 milliampere is putting 10 now. 10 into 10 is 100. So I need 10 milliampere to push it to 100 divisions. So this is going to be the value of Ig. That is the meaning of full scale deflection current. So this is a hidden information. You took it out. Clear? Okay. This is a full scale deflection current and this is going to be 0.01 ampere. Similarly, let's check the voltage sensitivity. What are they saying for voltage sensitivity? 2 divisions per millivolt. So for 1 millivolt, I am able to push the pointer to 2 divisions. Right? Now I need to understand how much voltage I'm supposed to supply to make it move to the 100th division. So 100th division, what should happen? How many times? 2 is 100. 50 times no. So this should go to 50 millivolt. Even without calculating, you can say, see, this increases by 50. This should also increase by 50. So that is why it is 50 millivolt. So this is the voltage that is required for full scale deflection. What is this? This is the current that is required for full scale deflection. Makes sense? Right. Now, what is the second part of the question that they asked? What are the adoptions that you need to do so that it becomes a ammeter of which can measure 5 ampere of current? So for that, what are we supposed to do? So here, if you see, Rg is also not known to us. You need to convert it to a ammeter. R shunt is equal to formula another. Ig into Rg divided by I minus Ig. So in that problem, I is given. What is the expected I value? 5 ampere. Ig we found out, right? Ig you can substitute it, but we don't know what is the resistance of the galvanometer. How will you find the resistance of the galvanometer? So Rg, resistance of the galvanometer, you can find it using this full scale deflection voltage divided by full scale deflection current, because can I write the voltage across the galvanometer is equal to the current across the galvanometer into resistance of galvanometer. Basic Ohm's law. Vg is equal to Ig into Rg. So Rg will be equal to Vg by Ig. You found Vg, you found Ig. Now, did you understand why did they give voltage sensitivity in this problem? Why is it important? For you to find galvanometer's resistance. So if you observe in this problem, everything is hidden. You have to find and then do it. So am I clear till this step? Are these steps clear? After that, you yourself can do it, no? So shunt resistance, can you calculate how much is the value? Ig is known, 0.01. Rg is known, how much is that? 5. So 0.01 into 5, 0.05 divided by I minus Ig, 5 minus 0.01, right? 5 minus 0.01, it will be 4.99, I guess. Yeah, it will be 4.99. So numerator you have 0.05, denominator you have 4.99, multiply with 100, it will become 5 by 499. And observe, Sai Kalyan, you asked me a question. No, sir, for every problem are we supposed to approximate? Don't do it. In this problem, you have only till 2 decimal values. The previous problem, it was 7.5 and 4 into 10 power minus 3. That is why I did the approximation. In this problem, don't do it, because these are all measurable quantities. So if it goes to milliampere, then do it. Is that clear? So 5 divided by 499, you need not convert it, you can leave it as a fraction also. So that is the amount of resistance that you need to connect to convert it to an ammeter. Then what about a voltmeter? So for voltmeter, you need to connect a series resistor, right? So for conversion into voltmeter, what did they ask? For voltmeter, again, there is one twist. They didn't tell you directly how much is the volt they want. 1 division per volt means for 100 division, what should it measure? 100 volt. So what is the value of V? 100. So V is 100 divided by everything else is known, substituted. Did you understand? Right? Mark it as a very important problem. See, this problem is slightly tough only. I'm not saying it is easy, but if at all it comes in exam, instead of going and asking why did they give so tough problem, better you solve it. Okay? As long as you're clear with the logic. Clear? Right? Okay. So next one is easy. You can solve it. We'll do some simple problems and wind up. Okay. So do this. An ammeter of resistance 0.8 ohm can measure up to 1 ampere. Ammeter of resistance. So what have they given here? It is not the resistance of the galvanometer, it is the resistance of the ammeter. So an ammeter of resistance 0.8 ohm. So resistance of ammeter is 0.8 ohm, can measure a current up to 1 ampere. What must be the shunt resistance to enable the ammeter to measure current up to 5 ampere? Now, this ammeter of resistance 0.8 is able to measure the current till 1 ampere. Right? They didn't ask what should be the resistance of the ammeter to measure the current up to 5 ampere. Rather, they asked what should be the shunt resistance that you need to connect to ensure that the value of current is increased to 5 ampere. Right? How to solve this? How to solve this? So what is the resistance of the ammeter? It is Ig into Rg divided by, sorry. Resistance of the ammeter is going to be resistance of galvanometer into shunt resistance divided by Rg plus R shunt. How much is this value? It is 0.8. Similarly, this I is there, no. So what is the formula for R shunt? It is equal to Ig into Rg divided by I minus Ig. Right, here none of the values are known to us, right? So if this value has to increase to 5 ampere, then how much is the shunt resistance we need to connect? Hmm. 1 ampere. So it is going to be Ig and this is Rg. This is going to be A minus Ig. Okay. So tell me, what is going to be the value of R shunt in the first case? R shunt in this case is supposed to be Ig into Rg divided by 1 minus Ig. Correct? Why 1? Because it is 1 ampere. So what should be the value of shunt resistance in the second case? It should be Ig into Rg divided by 5 minus Ig. All that we need to find is what is the full scale deflection current. If you know that value, we'll be able to find the remaining values. Which one? Here, that's what so you want to say that the answer is going to be 4 ohm. That is the problem. Had this been shunt resistance of 0.8, then you could have told 4. They didn't give the shunt resistance here. Rather, they gave you the resistance of the whole ammeter itself. Okay. I'm missing some logic. Let me check. So just a minute, I'll put on. So Ig is 1 ampere, Rg is. So here what they have done is, this resistance of ammeter is there, no? That is approximation. Sorry, it was my mistake. So this ammeter itself was treated like a galvanometer. So when you do this, then we can take this as Rg. Then Rg will be 0.8. Now you can substitute it here and find out. Ig is what we need to find. No? Ig and Rg anyways will get eliminated. Okay. So what is the combined resistance of the ammeter and the shunt? So 1 minute. So Ig is, what did I get? Is 1 ampere. Okay, the approximation was done here because I missed the logic. So if you take that to be the value, then Ig will be 1 ampere. I'll come from the beginning. I'll explain it. Listen to this. Forget this. So explaining it from the beginning, listen to this. An ammeter of resistance 0.8 ohm can measure current up to 1 ampere. Okay. So this ammeter itself can be approximated and considered as a galvanometer. The reason why we can do this for ammeter is because the shunt resistance that you're going to connect is going to be of very less value. Okay, why you can do this approximation is, I'm repeating it again, listen to this. This you can do the approximation only in the case of conversion of a galvanometer to ammeter. Why are we doing it? Because this resistance is going to be a very less value. When this resistance is very less, it is approximated. The whole device can be approximated to ammeter itself. To give you a conviction for this, if you observe, you can ask me how you can do this, but listen. You remember this problem? In this problem, I did one approximation. You remember what is the shunt resistance that we have connected? When we solved this problem, we got the shunt resistance to be 4 into 10 power minus 3. You remember this? Now, in the same problem, they asked what is the resistance of the ammeter. So what is the resistance of the ammeter? It is still 4 into 10 power minus 3. Why is it happening? Because the value of the shunt resistance is approximated. The same logic is applied in this problem. Okay. So same logic is applied here, because if this is not taken, we have too many variables to handle. I wrote the expressions, no, that would have happened. So RG is going to be equal to 0.8 ohm. Since you take this ammeter itself to be a galvanometer, then what will this current become? That will be the full scale deflection current, which will be 1 ampere. Now, I think you will be able to calculate what is the value of shunt resistance you need to connect. So what is the value of shunt resistance? R shunt is equal to Ig into Rg divided by I minus Ig. What is Ig into Rg? It is 0.8 divided by I is 5 minus Ig is 1. So 0.8 divided by 4, which will be 0.2 ohm. So this should be the shunt resistance that we need to connect it to, convert it to an ammeter of which can measure up to 5 ampere. So what is the combined resistance of the ammeter and the shunt? 1.6. Every one varum 0.8 plus 0.2, which will be 1. Let me check if that is right. But 0.16 is given. Which one? Sorry. Adama, resistance of ammeter, but this is considered as a galvanometer itself. Because this galvanometer is only converted to this ammeter, no? See, when you take this to be the basic structure to which you are doing a change to convert it to a new ammeter, which can measure up to 5 ampere, this basic is fixed, no? So Ig into Rg, I'm going to use the same values. So full scale deflection current is 1 ampere into 0.8 divided by what is the new ammeter's current that it's supposed to measure? It is 5. 5 minus 1, it will be 4. So that is going to be 0.2. Now, what is the combined resistance of the ammeter and the shunt? Okay, I'm sorry. See, this is the ammeter, Lada. He's right. This is ammeter, no? Because the ammeter is approximated to the galvanometer is what is considered to be the ammeter, no? And this is a shunt resistance. So since they both are connected in parallel, so what is going to be the combined effect? Ra will be equal to Rg into R shunt divided by Rg plus R shunt. What is Rg? 0.8 into 0.2 divided by 0.8 plus 0.2 is 1. It will be 1.6 ohm. Okay. Two decimals, sir. Okay. So 0.161. Fine. Are you clear? So I thought I'll start the next chapter, but these problems took so much time. Could you understand? So just to give you a conclusion, right? These kind of problems are important. The next two sets that I taught you are slightly of higher order thinking. They might come, they might not come, but it completely depends on how the paper is. So one important thing here is you will have an exam called as clusters. So before your board exam, you can treat it like pre-board, where your internal marks will also be taken into consideration. During that time, what will happen is there will be a common paper for almost 6 or 7 schools. So in those exams, you can expect these kind of questions, which I did. In those exams, you can expect, so which might take a hit on the internal marks if you don't know. But for boards, 99%, I'm sure that this level of toughness will not come. But for that exam, you can expect it. Is the point clear? Right? So it's better you practice them and understand. If you don't know, if you're not able to understand, reach out to me. Clear? Right. So with this, we are done with all sorts of problems from this chapter. So next is we are supposed to start with 5th chapter. So 5th onwards, it will go very fast. Because all will take, as I told you, 2 to 3 classes maximum. So 5th chapter, I'll take only 1 week. So tomorrow I'll start. Next week I'll complete it. 6th chapter, 1.5 weeks. It will go like that. Okay. So yeah, that's it. Any other questions? All are clear?
Sir.
So last one. Solution வேணுமா இதுவா பாரு